Okay, so this is Unit 8, Day 6 for Algebra 2. Pretty sure Day 5 was a quiz of some sort, so we skipped that. We're going to do polynomial long division today. So for those of you who looked at the review sheets from when we were out of school, the first review sheet was about rationals. And there were 4 or 5 questions that I put on there that I apologized for because you hadn't had it yet. Those were the questions that required polynomial long division. So you are now going to learn how to do that. But before you do, I'm going to have to take you down a trip into memory lane to 3rd or 4th grade. That's when you first learned how to do long division. And then somewhere in middle school, we stuck a calculator in your hand, and most of you don't even do it by hand anymore. So I need to go and reteach you what you're going to do. All right, so use long division to find the answer to 125 divided by 3. So 125 goes under the division bar, the 3 goes outside, okay? So what you do is you take the 3 and you look at the first place, which is a 1, and can 3 go into 1? The answer is no. So then you look at the first 2 places together. Can 3 go into 12? Yes, it can. So now you figure out how many times 3 can go into 12. Well, 3 times 4 makes 12, so you put 4 over the back of the number. So you put the 4 over the 2, and yes, the place matters of where you put your answer on top. 4 times 3 is 12, so you would write it down. Then you would subtract that. 12 minus 12 is 0, which we don't need to write. And then you bring the next number down. And you repeat the process. So, how many times does 3 go into 5? It goes once. So you put a 1 next to the 4. 1 times 3 is 3. Write it down. Subtract it from the 5. And you get a 2. Now, there were a lot of different ways to write your answer. One of them was as a fraction. Well, first of all, the first thing you learned was to call it 41 with a remainder of 2. And then when you got into a little more advanced mathematics, you called it 41 and 2/3 because you have 2 out of 3 left. And then when you got into higher level mathematics, you just added a decimal and some zeros and kept dividing, and you would have gotten 41.6 repeating. Okay. This middle form is the one that we're going to need for our polynomial long division. So 41 is the quotient because that's the answer. Okay. The divisor is what you're dividing by. So the divisor is 3. And the remainder is what was left when you finished the problem and got done subtracting. So the remainder was 2. So the way we write our answers in this middle of the road level is the quotient plus the remainder over the divisor, 41 plus 2/3. That's what you learned back in elementary school. Well, now we're going to jump back into high school, junior year, and now we're going to divide polynomials. And it's going to be the same basic process, just a whole lot uglier. Okay. You will often see the directions like you have here. So it says divide that polynomial by x plus 1. Write your answer in the form of q of x plus r of x over d of x. And right above in boldface, I wrote what that means. The q of x is the quotient, which is going to have x values in there, so it's going to look like a function. The divisor, what you're dividing by, goes in the denominator of that fraction. We're dividing by x plus 1. It's a d of x because it kind of looks like a function, x plus 1. It's a polynomial. And the remainder will probably be a polynomial as well. Okay, so they want us to write it in the same form that I wrote the one above, the 41 plus 2/3, except now in Algebra 2, we're going to have a whole bunch of x's floating all over the place with it. Okay, so here goes. What you're dividing goes underneath the division bar. One thing to note, and I will point it out in a problem where we absolutely need it, but you want to make sure every exponent is represented in this polynomial. So I have an exponent of 3, then 2, then 1, then 0. So from 3 down, all of my exponents are there, and that is crucial. And I'll tell you what to do when they're not there when we get to that problem. So we're going to take that function and we're going to divide it by x plus 1, which is more than one term. So it's very similar to what we did above, except above we just had one number to divide. Now we've got 2 terms. So how many ever terms you're dividing by tells you what position to start writing your answer in. So if I've got 2 terms to divide by, my first answer goes above the second term of what I'm dividing into. Okay? Now, the number in front of this x is 1. So in order to do this, I need to figure out 1x times what will give me an x cubed. So 1x times what will give me an x cubed? Well, that would be an x squared. So that's what I write at the top of my division bar, is that x squared. Now I'm going to take that x squared, because x squared times x will make x cubed, and I'm going to distribute that x squared to both of them. So x squared times x is x cubed. X squared times 1 is a positive 1x squared. The next step, like we did above, was to subtract what we got from what we have. Well, I've got 2 pieces here, and I need to subtract them both. Well, if I subtract a polynomial, I have to distribute my negative. So, to make a long story short, when you subtract on this step, you change both signs. That's the subtraction step. Change both signs. That's you distributing the minus sign. Now, combine like terms. X cubed and negative x cubed, cancel. Go away. They're supposed to go away. If they don't, then you didn't pick the right thing to put at the top. Okay? Negative 5x squared minus 1x squared is negative 6x squared. That's the end of round 1. We need to do it again. All right, so now I'm going to change to purple. All right, so after round 1, we bring the next term down and do it all over again. So now I take a look at this 1x over here on the left and this negative 6x squared. What do I have to multiply a 1x by to turn it into a negative 6x squared? I need to multiply it by negative 6x, and I'll put that over the next term. Now I take that negative 6x and distribute it to both of the dudes on the outside. So negative 6x times 1x is negative 6x squared. Negative 6x times the positive 1 is negative 6x. And now I'm on my subtraction step. In order to subtract, I need to distribute the minus sign, which changes both the signs here. Now I combine like terms. Negative 6x squared plus 6x squared cancels out like it's supposed to. 3x plus 6x make 9x. End of round 2. Start round 3, bring down the last term, and we do it again. All right, so now I want to take a look at this 1x and ask myself, 1x times what will make a 9x? Well, 1x times 9 will make a 9x. So it's a positive 9. Make sure you put the plus to keep it separate on the top of your division bar. And now I distribute the 9. 9 times 1x is 9x. 9 times positive 1 is positive 9. Don't get too excited that you're close to the end of the problem. A lot of people stop now or do something really silly. You're not done yet. You need to subtract both of these. To subtract, you change both signs and do what it says. 9x minus 9x cancels. Negative 2 minus 9 is negative 11. And we are done because there are no more terms to bring down. So at this point, all we have left to do is write our answer in the format that they asked for, which is the quotient found on top, x squared minus 6x plus 9, plus the remainder, which is negative 11, over the divisor, which is what we were dividing by, x plus 1. That's the answer to our division problem. That should kind of look like some of those multiple choices on that first review assignment that we gave you when we were off. All right, next one. Instead of giving those elaborate instructions to divide, they could just write it like this, which is why I accidentally put those problems on your review sheet to begin with, because this is a rational expression. So the first thing we would try to do, like we learned back in September, is to try to factor and cancel. Well, I can pull an x squared out of the first group and I get 2x plus 1, but the only GCF of the second group is a 1, and since my parentheses don't match, I can't go any farther, which means I can't factor this. So if I can't factor it, my alternate method now is to use polynomial division. So I'm going to take whatever's on top and put it underneath my division bar, and the denominator is my divisor. And here we go again. All right. First of all, check to make sure you have all your exponents. Here's a 3, a 2, a 1, and a 0. So all my exponents are there. Now I'm ready to start. So I have 2 terms that I'm dividing by. That means my answer will first go up here, which brings me back to something I forgot to mention. On this first problem, when you look at your answer on top of the divisor bar, do you notice all the x's line up? So like x squared's on top of x squared, the x is on top of the x, and the 9 is on top of another number? That should always happen. So that's another way to help you line up your answer on top of your bar. Okay, so what do I have to multiply to an x to get a 2x cubed? Well, I need a 2, and I also need an x squared. So now I'm going to take that 2x squared and distribute it to both the dudes on the outside. That gives me 2x cubed. And 2x squared times negative 2 is negative 4x squared. I now want to subtract. To subtract, I distribute my minus, which changes both signs, and do what it says. 2x cubed minus 2x cubed cancels. Positive 2x squared plus 4x squared makes it 6x squared. Bring down your next term. Do it all over again. All right, look at the first term of your divisor. It's an x. What do I have to multiply to x to turn it into that 6x squared? I need a positive 6x. Distribute the positive 6x to both of those guys. You get 6x squared and negative 12x. Subtraction step, change both signs. Do what it says. The 6x squareds cancel as they should. Negative 13x plus 12x is negative 1x. Bring down your last term. Do it one more time. Okay. Look at your x. What do you multiply by x to make it a negative 1x? You multiply by negative 1. Okay. Distribute your negative 1, and you get negative 1x. Positive 2. Subtract means change the signs. Do what it says. You end up with 4. All right, so our answer is 2x squared plus 6x minus 1 plus the remainder over the divisor. This is our final answer. So, what was the remainder? Well, the remainder was 4. And what does this mean? Well, it means it cannot be factored. So I'm not sure why I said write it out in factored form. I'm guessing that I had a typo here. Okay. But just in case, okay, I've seen this show up like once or twice on our Regents to be confusing. You can write it sort of in factored form. So what it's saying is, if you take that x minus 2 that you're dividing by, multiply it to the 2x squared plus 6x minus 1, you will almost get the original problem over here. But in order to get the absolute original problem, you would have to add the 4 onto it. So if you take what you divide by, multiply it by your quotient on top, and add the remainder, if you were to multiply all that out in combined terms, you will end up with their original problem. So that's what I think they mean by write it in factored form. Okay. That's not true factored form because this 4 is not a factor. Okay. It's kind of an add-on at the end. So if you have a remainder of 4, that means that that method that we tried in the beginning of factoring and canceling is not going to work. All right. I'm a little confused here. My apologies. I'm going to cross this off because that's the last question. We just addressed it. They want to know what the roots of this are. No, they wanted that at the last one. All right, so we're going to just cross that off. That has to be a typo on my end. And that one too. My apologies. This is a mess. All right, let's go down to example 4. So, oh, that went with example 4. Man. Okay, when this saved and I uploaded, things happened strange, as you can tell. So this y thing here is the h of x for example number 4. So h of x is equal to y cubed minus y squared minus 17y plus 3. All right, now things are starting to make sense. So for example 4, they're giving you h of x. And then they give you another function called n of x. And they're asking you to find h of x over n of x. And this symbol right here, the fraction bar, really means divide. So this is now 3 examples and 3 different ways to ask you to do the same thing. All right, we're dividing. So y cubed minus y squared minus 17y plus 3. And we're going to divide it by y plus 3. All right, here we go. 2 terms, so my answer starts up here on the second term. What do I multiply to the y to get a y cubed? I multiply by a y squared. Distribute the y squared. We get y cubed plus 3y squared. Subtraction step. Change the signs. The y cubes will cancel. Negative y squared minus 3y cubed is negative 4y cubed. Bring down the next term. Do it again. So what do I multiply this y by to get a negative 4y cubed? I need to multiply it by negative 4y. So now we're going to distribute the negative 4y. So negative 4y squared minus 12y. Subtraction step, change both signs. The 4y squareds will cancel like they're supposed to, and we get negative 5y. Bring down the last term and do it one more time. What do I multiply y by to get a negative 5y? I multiply it by negative 5. So distribute the negative 5. Negative 5y minus 15. The subtraction step means change both signs. The y's will cancel. I end up with 18 for a remainder. So my final answer is y squared minus 4y minus 5 plus 18 over my divisor of y plus 3. So what was the remainder? The remainder was 18. What does this mean? This means that y plus 3 is not a factor of y cubed minus y squared minus 17y plus 3. We're going to go back and change that last example. So instead of saying it cannot be factored, what we're going to say, which is more appropriate, sorry I lost my wording, x minus 2 is not a factor of that. Okay, it might be able to be factored, but x minus 2 is not one of their factors. Okay, so if you get a remainder of 0, that says what you divided by is a factor of that polynomial. If you don't get a 0, what you're dividing by is not a factor. That's going to be a big deal, and it's going to have a lesson all of its own coming up. All right, so this ends day 1 of polynomial division. All the problems that we had today had all the exponents that we needed, the 3, 2, 1, 0. So I'm pretty sure that they should in your homework as well. Tomorrow, the next lesson, we are going to do more polynomial division, and we will address what you have to do when you're missing some exponents in your polynomial to start with. So give the few homework problems a try, and good luck.